Welcome back everyone to the Hello World Guide. This is another episode of the OpenGL renderer series, and in this video we are going to create a class to abstract away our shaders, and we are also going to learn a way to kind of have different variables in our shader. So currently we've got this code in our shader that allows us to have yellow color, but we don't want to have to write a different shader for every color that we need to do. So how can we make it in a way so that we can change the color of the shader without having to rewrite a different shader? So for each different object we can have different colors, but we won't have to write a different shader for each of them. So how can we do that? And before we do that, we'll first create a class to abstract away the details of the shader. So in order to do that, what I'll do is that I'll go ahead and create a class here, a new class called shader. So we'll right click on this, go under add and choose a class, and for the name of the class you can just say shader, so that we can, this will make it easier to create multiple shaders and stuff like that, so it will be easy. So what we can do is we are going to go here, and you might want to include here we actually don't need to include gl/glue in the header file. I'm going to go ahead in here, and you can see this is basically all of our code. For that we'll have to first of all, let's include string, and we are going to take in a std string, a standard string, instead of a c string, because that gives more flexibility, and c strings are convertible to standard strings anyways. So what we are going to do is go ahead and create a const std. We are going to take a const reference. The only reason we are taking a const reference is because that is better performance wise. So we'll take a const std : string reference, and we'll call this vertex code, and we'll take another one which we'll call fragment code, and this is basically all that our shader will contain, and it will set up everything in the constructor. So we'll do that, and yeah, that's pretty awesome. So now what we are going to do is we are going to go under here, and under shader we can just go ahead and create its definition in shader.cpp, and you can see we've got this here. And what we are going to do is we are going to basically copy all of this things that we have got here and go ahead and paste it inside of the this here. And what we'll have to do is we'll have to make sure we include gl/glue.h here. And another thing is that you can see we are using c error here for error output, and we'll have to include iostream as well. So let's just say #include iostream so that we can actually access that. So that is pretty awesome. And now for the vertex code, you might want to say vertex code.c string, but it won't allow us to do that automatically without like directly. So what we'll do is we'll first store this in a variable. So I'm going to undo that right now, and what we are going to do is we are going to create a const character pointer called vertex shader code, not vertex code, just vertex shader code, which we are going to set it to the c string version of vertex code. So vertex code.c string, and we are going to do the similar thing for fragment code. Create a c string here, const character pointer called fragment shader code, and set it to fragment code.c string, and that is pretty much all we need to do. And of course we like to keep track of the actual shader id inside of here. So what we'll do is we'll go in here, and we'll create a private variable here called we'll just make it a uint32 called let's call it program id. So it will be an unsigned integer called program id, and that's pretty awesome. What we are going to do is one thing we want to make sure is that now we use program id here instead of this shader variable we have got. So we'll say program id, and we must not redefine it, but instead use the member variable. So we'll go and set the program id, each of that, to the correct value, whatever we need to have. And after that what we can do is we are going to create another function for using the shader, because of course we want to use the shader. So for that we'll have to create a function called use, and this is going to take no arguments, nothing. So in here it's pretty simple to implement. We can just go ahead and say gl active shader, and actually yeah, this is the wrong function. It's not what we want to do. So if you remember, in here we use gl use shader, not gl active shader. So yeah, like that. So I'm just going to copy that statement and paste it here and replace the shader without program id, and that is pretty much it. So for actually using this, we can go under our main file, our main program here, And what we can do is we can just remove all of this and instead just replace it with a single shader. In the constructor we are going to give it the vertex shader code and the fragment shader code. So yeah, let's just pass those two, and we are going to call this variable shader. And of course shader is not included yet, so we'll have to make sure that we include shader.h here up here. And yeah, that should basically allow us to create our shader in a modular and object oriented way. And when we want to use, we are going to say shader.use, just call that function and call mesh.draw, and yeah, that is pretty much it, and that is going to still work correctly. So one thing you can probably notice is that we have got a yellow color defined in our fragment shader, and if I run my program, we do get a yellow rectangle, a square, actually a yellow square on the screen. So if I run this, you can see that we do get a yellow square on the screen. Now imagine we want to have a different color for the square, say blue. We'll have to set the red to 0, the green to 0 as well, and the blue to 1, and well, that would give us the blue color. And imagine we want to draw 2 or 3 or 4 squares, and we want each of them to have a different color. Then what we'll have to do is we'll actually have to set a we'll have to create a different shader, different set of shaders for each of those. And of course that is very impractical. We do not want to have to create different shaders for each different color that we want. So instead we are going to use parameters using uniform. So here I am defining a uniform vector tree called color, and this will allow us to have the same shader but define different values. And when we are setting the fragment color, we'll use color but convert it to a vector 4 and set the alpha value to 1. And in order to set different uniforms, we'll go under our shader class and create a member function called set value. And different types are going to have different functions for setting the values, but since C++ supports operator overloading, we can just have a single set value function and basically overload it multiple times to have different kinds of things here. So for the actual we'll take of course the name of the uniform that we want to set, and we'll take a glm vec3 called values, because currently we only need the vec3, so we will only have the vec3. Be sure to include glm. And as we want more different types, if we need different types, we'll keep adding set value functions for those. And OpenGL has got a bunch of different functions for setting different kinds of things here. And we want to set a vector 3 which is made up of floats, so we'll call the function gl uniform 3f. So gl uniform 3f. Now each of these gl uniform functions requires us to provide it with the location for which we can, for the location we can just say gl get uniform location, and it requires us to provide it with the program ID, which will do that, and provide it with a C string name as well. So that's pretty awesome. And for the actual value, we'll just pass the 3 parameters like it has asked us to, value.x, y, and z, and that is pretty much it. That's how you set a vector 3 for a uniform variable. And now that should allow us to basically do that in a much more robust manner. And for different kind of things, we can just use a similar method for different types of variables. So now what I'm going to do is when I am running my program, before I maybe you can do that once, or you can do that in each loop if it needs to change or something. So we can go say shader.set value, and for the name we can just pass the name color, and for the value we can just say glm : vec3, and for this we are going to say red, and we are going to pass a red color. Actually let's set the green to 0, or perhaps let's set it to 0.5 so that we get a pale red. So yeah, we'll just pass in that, and what you should see is that now we get a rectangle, a square that is pale red. So the color should now be according to whatever we set it, and what you should see is that that does work. And if I close that and I change the color here, the color will actually change in the program as well, and without us having to actually modify the fragment shader. So I'm going to modify the color to be a bit of a pale yellow kind of color. So yeah, let's set it to that, and what you should see is that we do get that color as well. And if you want to draw multiple meshes, we can just set the uniform variable for different meshes. We can set it to be different. So if you want to draw another mesh, we can just copy this, and we can draw the mesh again with the different colors. So we can just pass a different color in the second try. So yeah, that is pretty much how you use uniforms in OpenGL. So yeah, this is pretty much it for this video. In this video we learned how to do this kind of shaders, and in the next video we are going to learning about cameras and projection sections and views, so that we can stop having to specify stuff in normalized device coordinates. And we can also create a method to kind of have 3D effects in our scene by having like a 3D moving camera or something like that. So that is going to be pretty awesome, so stay tuned for that. I'll see you in the next one. Make sure to like and subscribe as well, and share this video with other people, and bye.